Good morning students. We will continue the previous class. In that previous class we were discussing about the refraction through a spherical surface. Yes, I said in last class it's a very important. See, we have been till here in that previous class. I was saying for this right angle, for this triangle NCI, for this triangle, this angle is looking exterior. Angle NCM is exterior angle to this triangle NCI. To this triangle NCI. So, if it is exterior, then what we can write? We can write that exterior angle is equal to the sum of opposite interior angles. Opposite this angle, this NCM is equal to the sum of this angle and this angle. I mean R. This angle is R plus NIC. That I have written here. Okay, that exterior angle NCM is equal to sum of interior angles R plus NIC. Here I write. Then we continue that. See here. Look on this one. I just taken this angle that side. Then R is equal to angle NCM minus angle NIC. That I have written here. R is equal to angle NCM minus NIC. Now that equal to that NCM I have written as usual minus as usual. That NIC I replaced by NIM. NIC angle I replaced by NIM. Why? Look on the diagram. NIC, NIM, both are same. Look, NIC, this angle, NIM, again that angle. That's what they are saying. So I replaced that NIC by NIM. Now you go with that. R is equal to NCM from here. Yes, NCM means NM by CM. NM by CM minus NIM. Here NIM is NM by MR. NM by MR. Name it as equation number 2. This equation number 2 is giving the value of angle of refraction. R is angle of refraction. What about equation 1 is telling? Equation 1 is telling the value of angle of incidence. Angle of incidence, angle of refraction. Now, according to the Snell's law, what we can write? That Snell's law saying N1 sin R is equal to N2 sin R. Here I have written that Snell's law. From Snell's law, I mean that I have written. Okay, see here. N1 as usual there. Sin I replaced by I, and sin R replaced by R only. Already I said in previous class, for small values of angles, if you apply sine function to that angle, then that value even is being equal to, is being nearly equal to that angle value. I mean, for any small angle, sine of that angle is equal to that angle only. I mean, sine of theta is nearly equal to theta. Getting what I mean? That's why sine of r is equal to I and sine of R is equal to R. So here I have taken sine of I, nothing but equal to I, sine of R is equal to R. Yes. Now look on that. N1 as usual we have written here. In place of I have written this according to equation number 1. That equation 1 giving the value of angle R. See here, I is equal to Nm by Om plus Nm by Cm. That we have written here. Okay, look here. In place of I, we written that value is equal to N2. In place of R, you have to take the respective value from equation number 2. Equation 2 giving the value of R. R is equal to this. I have written here. Okay. Yes. N1R is equal to N2R. Next, simplification is there. See, look on these two. I mean on LHS side and even on RHS side. Here in the numerator, Nm is there. This you can take as a common outside. This side also in the numerator, Nm is common. So even this side also you can take that Nm common in the numerator from out of that box. This side Nm and this side Nm both will get cancelled. Okay, fine. Then you will be being with N1 by Om plus N1 by Cm, that I have written. Similarly here N2 by Cm, then minus N2 by Mi. Okay, see here. Now look on this equation. Both sides we taken that Nm out. Okay, yes, we cancel that. Now you see here what we have to do. Okay, now here Cm denominator looking common. So you take this Cm that side. I mean you take this term that side. Then it will become minus. Okay. Then you take this side here. N1 by Om as usual I have written. This N2 by Mi I have taken this side. That's why that becomes plus. N2 by Mi. That equal to N2 by Cm we have written as usual. N2 by Cm. This one we taken that side. So it become negative. N1 by Cm. Look here on these two. In the denominator Cm is common. So you can write it here as a common Cm. In the numerator N2 minus N1. Yes, this is now one equation. To this equation, now you have to apply Cartesian sign conventions. Already we discussed what those, which are those Cartesian sign convention and what they are telling. Yes. According to Cartesian sign convention, we have to start to measure all the distance from the pole point. Okay. Then next thing, the distances which we measuring in opposite direction to the incident light, we have to take it as negative. The distance which we going to measure along the direction of incident light, we have to take as positive. Now we have to apply these only over here in this equation. So now look here, N1 there, N1 as usual I have written, Om there. What is this OM? Look on that diagram. OM. This is O and this is M. I mean that is which distance? Object distance. One more thing here you should know. Here pole is here. This is pole point. This is pole. This pole and this M, this distance. Okay, look here. If this angle is being very small, if this our entire analysis we treated for small angles, if this angle is going to become small, what happening? Look here. on this diagram. What I am going to say. If this angle, if light ray is going to incident at the top, then you will be drawing perpendicular like this. This is M, this is your P, this is your object, this is your that theta. For small values of theta, small value means light ray, if it incident like this, what happened? You see here, previous angle was more, right now angle is this much, angle got decreased. Now from this you have to draw one perpendicular. See there, that M point where it got shifted, that M point is coming towards the pole point. If still you make less angle, this is theta now. Theta is less. As theta is going to become small, that point M shifting towards the P. This point M shifting towards the pole. Over this entire analysis, we treated for small values of theta. For small values of theta, M is nothing but on P. Look on this. As we are decreasing the angle, M is shifting towards the pole point. Getting what I mean? I mean, for small theta, that M and P are same only. We treat M and P as a same. Getting? It's very important. Now here, from pole, I mean from M to O. O is object. Which distance? Object distance. U. From where you have to measure? From pole. I mean you have to measure from pole in that direction. This your measurement is in opposite direction to the incident light. Light is coming like this. You measure it like this. So that object distance is minus. So in place of this OM, here you have to take as in place of OM, here you have to take as a minus of U. Have you understood? Yes. Then plus as usual. N2 as usual. Divided by MI. Look on the diagram again. What mean MI? Look. I means already I said image. MI. Which distance? Image distance. Small b. Here, this is that. From pole to that eye point you have to measure. From pole you have to measure. Your measurement starts in this direction. I mean it is along the direction of incident light. So this image distance V you have to consider as positive because you are measuring that the distance along the direction of incident light. So MI that is equal to plus V. Okay. Here we have taken in place of MI we have taken plus V. Yes, that is equal to N2 minus N1 as usual divided by Cm there. Cm means what? Look on the diagram again. C is a center of curvature. M you nothing but treat as pole point. The distance between center of curvature and pole we call it as a radius of curvature. That radius of curvature is going to represent with capital R symbol. This is radius of curvature. That distance also we have to measure from pole point only. This distance also you have to measure from pole towards the sea. Your measurement is going in this direction. I mean it is along the direction of incident light. So you have to take this MC or Cm as a plus R. So now look here on this one. Where that Cm is there you have to write plus R. Okay. Yes. So now here you write that equation again like this. I mean same equation only I am going to write like this type. Okay. Yes. So now you see here. This one only I have written like this. N2 by B I have taken this side. I mean N2 by B minus N1 by U is equal to N2 minus N1 divided by R. Yes, this is a final equation. This equation 3 is a final one, and according to this equation, look on this equation here. What these N1 and N2? N1 is the refractive index of that first medium, and N2 is the refractive index of second medium. U is the object distance, V is the image distance, and here R is the radius of curvature. Okay, this equation 3 or this expression giving the relation between object and image, object distance, image distance, refractive index, and radius of curvature. Okay, in exam they will be asking this derivation. Derive an expression which is going to relate the distances, refractive index, and radius of curvature of a spherical surface. At that time we have to derive this derivation. I mean refraction through a spherical surface. Here one thing you have to notice. Okay, we kept object in rarer medium. We got their image in denser medium. This derivation there for your syllabus. Okay, one more derivation we can derive here. Even we can reverse this. We can take this reverse. Treat this one as object, and that will be image. Look here. If you go reverse, if you go with a reverse analysis, if you treat this as an object, obviously that will be image. In that case, you kept object in denser medium. You will be getting their image in rarer medium. For that case, there will be different derivation, and finally you will be getting one different expression. Okay, that's why you think here this expression which we got, it is for that in which we kept object in rarer medium, and their image we got in denser medium. Okay, yes. Further later, as we moving, we will be getting lens, and will be seeing their different types of lenses, and will be going for lens maker's formula. We'll be deriving one equation there. While deriving that equation there, we will be using this equation. Okay, we will be using this equation. This even one more which I said, reverse analysis. I mean this, when object we kept in rarer and image we got in denser. And one more reverse analysis, object in denser, image in rarer medium. Anyhow, this is very important. Go with this derivation. Okay. Then after this one, after this refraction through a spherical refracting surface, now we entering into one more optical medium called as lens. After this derivation, according to your that syllabus, we will be having refraction through a lens. Refraction through a lens. Then we should know firstly what do you mean by lens. What do you mean by lens? Lens means it is an optical medium. Lens means it is an optical medium bounded by two surfaces, of which at least one should be spherical. Lens means an optical medium bounded by two surfaces, of which at least one should be spherical is called as lens. A lens is mainly classified into two types. One is convex lens and another one is concave lens. This convex lens even we call as a converging lens. Why we call converging? Later I will tell you. And to that concave even we call as a diverging lens. We'll see why that concave is diverging and why this convex is converging lens. Yes. Before that, firstly, how we have to identify them as a convex and as a concave. If that lens is thick at the middle, thick like this, you see here, look like this. I mean, see here, this one. Look here, this is the lens. Okay, how this lens looking here? The geometrical midpoint of that lens we call as optical center. Actually, already I said lens bounded by two surfaces of which at least one should be spherical. Here in this one, I mean this lens is made by two surfaces, this side and this side. Both are spherical here. Both are spherical. This lens right now is a part of two imaginary spheres. This lens right now here is a part of two imaginary spheres. Means to this first surface, here you can imagine one sphere like this. Okay, this imaginary sphere being with its own center of curvature. Okay, and here one more curved surface there. This is also a part of one more imaginary sphere. Look here. This curved surface is a part of this side imaginary sphere, and this curved surface is a part of this imaginary sphere. I mean lens is a part of two imaginary spheres. Here one and here one. See, look, this we call as lens. Their geometrical midpoint is called as optical center. Okay. Yes. Here this side. Okay. This is first refracting surface. So we call it as C1. C1 means what? Center of curvature of first imaginary sphere. And here one more center is there. This center. This is the center of this second imaginary sphere. So we call it as C2. Getting? So now, yes, this is optical center. The line which is going to join those center of curvatures and optical center, the line which is going to join them is called as principal axis. Right now this is principal axis. Getting what I mean to say? A line which is going to join the center of curvatures and that optical center called as principal axis. This horizontal line. Okay. Level. This is right now lens. Look on this much portion only. I said lens means optical medium bounded by two surfaces of which at least one should be spherical. Convex lens. Convex means it looking like this. Here I have drawn. This is convex lens. That looking. See, look on this position. How it looking? It is thick at the middle here. It is thick at the middle than the edges. Look on edge and at middle. At the edge it is thin, but at the middle it is thick like this. If a lens is thick at the middle and thin at the edge is called as convex lens. Is called as convex lens. This one is convex lens. One more is there, concave lens. Concave. If the lens is thin at the middle and thick at the edge, that looking like this. Like this. You see here, this is edge and this one is middle one. How it looking? Middle thin, okay, than the edge. It looking like this. See. Yes. This is also, this we call, this is actually convex lens and this is concave lens. So this lens also being, right now this one being with two surfaces. This is first one and this is another one. Again these two surfaces are also a part of two imaginary spheres. This is also, here one sphere you can imagine. Here also you can imagine one sphere. Again, see, this concave lens also a part of two imaginary spheres. Okay. Yes. Here there is a center point you call as C1, and here one more center point there that you call as C2. That line which is joining those centers called as principal axis. Okay. Here this concave lens also a part of two imaginary spheres. Look on this one. This is right now concave lens. This is middle portion and this is edge. Edge and middle, you see how it looking. At the edge it is thick. At the edge it is thick. And here at the middle it is thin. A lens which is thin at the middle than the edge is called as concave. Have you understood? A lens which is thick at the middle than the edge called as convex. A lens which is thin at the middle than the edge is called as concave lens. Okay, lens is mainly classified into these two types mainly. Then again, based on presence of their sides, again they classified or named in a different way based on presence of their side. How? This one you see on both sides. This is one side and that one is another side. On both sides this lens is thick at the middle. So we call this as a bi means two. On both sides it is thick at the middle. So we call it as a biconvex lens. Bi mean on both sides it is convex means, biconvex means on both sides it is thick at the middle. We call this as biconvex lens. One more is there. Look like this. This is also a lens. This is also a lens. Okay, made by two surfaces. Here this is one side and this one is another side. This side is plane. This side is plane and this side is thick at the middle. I mean it is convex. Here plane, here convex. So we call it as plano-convex lens. One side plane, another side convex. So we call it as plano-convex lens. One more is there. See here. I mean, look here. One side plane. Look on this lens. Look on this lens. One side it is plane, another side it is thin at the middle. thin at the middle.